So number 5 was an example of a problem where they give you the molarity and you're trying to find the pH. Number 6 is the opposite of that. What if they give you a pH and you want to find the molarity? It's talking about sulfuric acid. So we have to first think about what sulfuric acid is, H2SO4. It's an H2SO4 solution, and we're going to do only strong acids and bases that break up 100% in our class. So that sulfuric acid, when it breaks up, isn't it going to break up into an H+, another H+, and a sulfate? So I'll have 2 H+ and a sulfate. It tells me the power of my hydrogen is 2.7. Okay, so the power, the exponent of my H+ is a negative 2.7. Let me write that down. 1 times 10 to the negative 2.7 is my H+ concentration. Well, that's not a properly written number, but if you throw it in your calculator, it'll convert it into a properly written number for you. So depending on if your calculator is set up to be in traditional format or scientific notation format, you'll get an answer of approximately 0.001995. And that's a molarity when we're talking about concentrations, right? Well, that's the molarity of the H+ ion, but this one's the molarity of the whole solution, the whole chemical. So isn't that capital M an abbreviation for moles of H+ per liter? And I want the molarity of not just the H+, but the whole sulfuric acid. Well, you can see from my balanced up equation up above that there's 2 moles of H+ per 1 mole of H2SO4. So the molarity of my whole chemical is going to end up being half that of the ion. And so if we throw that guy in our calculator, we'd get approximately 0.009975 molar sulfuric acid. That could also be written, for example, as 9.975 times 10 to the negative 4th molar. Just make sure that you recognize both in case my answer key is written one way and you wrote down the other.